Now this video is a continuation of Unit 8, Lesson 4, and in this video we're going to work with division of radical expressions. So here we can use the quotient rule for radicals. So if we have the square root of 24 over square root of 6, for example, we can write that as the square root of 24 over 6, which is the square root of 4, which is 2. And the cube root of 1 over 64 we can write as a cube root of 1 over the cube root of 64, which is equivalent to 1 over 4. And the square root of 48x to the 7th y to the 5th over the square root of 6x cubed is equal to the square root of 48x to the 7th y to the 5th over 6x cubed, which is 8x to the 4th y to the 5th. And the largest perfect square factor is 4x to the 4th y to the 4th times the square root of 2y, and the square root of 4x to the 4th y to the 4th is 2x squared y squared. So we have 2x squared y squared times the square root of 2y. So try these problems, pause the video, try them out, come back and check your answers. So in the first problem, we have the square root of 48 over the square root of 3, which we can write as the square root of 48 over 3, which is the square root of 16, which simplifies to 4. And the cube root of 125 over 8 we can write as the cube root of 125 over the cube root of 8. The cube root of 125 is 5, and the cube root of 8 is 2, so that simplifies to 5 halves. And the square root of 28x to the 5th y cubed over the square root of 7x, we can write that as the square root of 28x to the 5th y cubed over 7x, which is 4x to the 4th y cubed. And we will have 4x to the 4th y squared times y, so that would give us 2x squared y times the square root of y. And another thing we can do is we can do what's called rationalizing the denominator. So sometimes we don't count an expression like this as simplified. So more often than not, we're asked to rationalize a denominator so that we don't have a radical expression in the denominator, and then that quotient will be thought of as a simplified fraction. So one way we can do that is we can multiply by what we have in the denominator. So if we take 6 over root 5 times root 5 over root 5 times root 5 is the square root of 25, which is 5. So we'll have 6 times the square root of 5 over 5. So now we have an expression that there's no radical in the denominator, so it's considered to be simplified. So using the same procedure, try simplifying 7 over root 3 by rationalizing the denominator. So pause the video, work on this, and then come back and check your work. Okay, so what we have here is we're using the same procedure. We can multiply 7 over root 3 by root 3 over root 3. Square root of 3 times square root of 3 is square root of 9, which is 3. So this simplifies to 7 root 3 over 3. In this example, sometimes we can do something that instead of just multiplying by the square root of 18a, we can figure out what factors do we need to multiply by to make this a square. So if I multiply root 18a by 2a, I get 36a squared, which is a perfect square. So this would be, we would have 10 times root a over the square root of 36a squared, and the square root of 36a squared is 6a. And 10 and 6 have a common factor of 2, so we can rewrite that as 10 divided by 2 is 5, 6 divided by 2 is 3. So we can say this is 5 root 2a over 3a, and that's a simplified version of the answer here. be careful, square root of a is not equivalent to a, so we can't cancel in that case. So if we have a variable that's underneath a radical and also it's not underneath a radical, we can't just cancel those. So this would be a simplified version of that. So try this one, pause the video, try multiplying by a number that makes the denominator a perfect square, and see if you can simplify that way. So 12 times 3 is 36, and x times x is x squared. So multiplying this expression by root 3x over root 3x, we get the square root of 36x squared in the denominator, which gives us 6x. So if we multiply the numerators, we get 3 times the square root of 3x. 3 over 6 reduces to 1/2, so we should, instead of having a 3 here in front, we shouldn't have that. It should be just root 3x over 2x. So if you have root 3x over 2x without that 3, that's correct. So if we're working with cube roots, working with this procedure to make a perfect cube in the denominator is helpful. So 8 is the next larger perfect cube. So 2 times 2 squared gives me 4. A squared times a gives me a cubed. B times b squared will give me b cubed. So that's why I'm multiplying by the cube root of 4ab squared in the numerator or denominator. So I get the cube root of 8a cubed b cubed in the denominator, and the cube root of that is 2ab. So we have 3 times the cube root of 4ab squared over 2ab as a simplified form of that. So try this one, pause the video, multiply 3x squared by something that gives you a perfect cube in the denominator, and then simplify that way, and come back and take a look at the solution. So here we have, I need to multiply, if I have 3 here, I want 3 cubed. So if I multiply by 9x, I'll have 27x cubed, and the cube root of 27x cubed is 3x. And the cube root of 2 times the cube root of 9x is the cube root of 18x. So this simplifies to the cube root of 18x over 3x. Sometimes we have a situation where the denominator has a sum, has a sum or difference of radical expressions, or something like 4 plus root 7. And an expression like 4 plus root 7 has what's called a conjugate. And all we do when we take a conjugate of an expression, a binomial expression, we change the middle sign to the opposite sign. So the conjugate of a plus b is a minus b, and vice versa. The conjugate of a minus b is a plus b. And when we multiply conjugates, we get the difference of 2 squares. And so that's going to help us remove the radical from a denominator. So in this case, we have negative 2 over 4 plus root 7. And if we multiply that by 4 minus root 7 over 4 minus root 7, we'll be multiplying by the conjugate. And so we take negative 2 times 4 minus root 7 in the numerator, and multiplying the 4 plus root 7 times 4 minus root 7, we can square the first term minus the square of the second term. So that's like 4 squared minus root 7 squared, which is 16 minus 7, which is 9. So this simplifies to negative 8 plus, that should be a plus 2 root 7, because a negative times a negative is positive. So that should be a plus 2 root 7 over 9. So try this. The conjugate of root 7 minus root 3 is root 7 plus root 3. So you'll multiply the numerator and denominator by root 7 plus root 3. So try that out and then come back and check your work. So here I've done that. I've taken root 7 plus root 3 over root 7 minus root 3, and I multiplied by the conjugate of the denominator, which is root 7 plus root 3. And then if we distribute the numerator, we'll have root 7 squared, which is 7. The outers will be root 21. The inners will be root 21. So we'll have 2 root 21. And root 3 squared is 3. So we'll have 10 plus 2 root 21 in the numerator. And then root 7 squared minus root 3 squared will be 7 minus 3, which gives us 4. So we'll have the coefficients are even, so we can factor out a 2. So we have 2 times 5 plus root 21 over 2 times 2. A common factor of 2 can be canceled. So we have 5 plus root 21 over 2. Okay, so we're dividing. In this lesson, we multiplied and divided radical expressions and rationalized denominators. And so we know how to simplify expressions if we're finding products or quotients. Okay, so practice with the written exercises and the online homework, and we will see you in class. Take care.